An electrical and pneumatic power source is required for engine start. These sources may be supplied by or in a combination of the APU, an external power ground air cart, or an operating engine. Also, the aircraft battery may be used as the electrical power source. 3-position engine start switches control the arming of the high-energy ignition system and the start valve solenoid. The switch is spring-loaded from the ground position to off. The engine start lever controls the energizing of the high and low energy ignition systems and the opening and closing of the fuel control and engine fuel shutoff valves. The start valve open lights monitor air pressure downstream of the start valves. The lights are extinguished when air pressure is not available. Moving and holding the engine start switch in the ground position arms the high-energy ignition circuit and energizes the start valve solenoid. Air pressure then opens the start valve, and the respective start valve open light illuminates. A decrease on the duct pressure indicator is a secondary indication of start valve operation. When N2 reaches 17 to 20% and N1 indicates rotation, the engine start lever is moved to idle, which activates the high-energy ignition circuit, mechanically opens the fuel control valve, and electrically opens the engine fuel shutoff valve, provided the fuel shutoff switch is in the open position and the fire handle is in. When N2 reaches 35%, the engine start switch is released, which deactivates the high-energy ignition circuit and closes the start valve, which extinguishes the start valve open light. The duct pressure indications rise when the start valve closes. The starter duty cycle is limited to a total of 90 seconds on, 5 minutes off, followed by 30 seconds on, and 5 minutes off. In flight, start valve operation is not required due to engine windmilling. Moving the engine start switch to flight arms only the high-energy ignition circuit. Moving the start lever to idle activates the high-energy ignition circuit and opens the fuel shutoff and fuel control valves. High-energy ignition duty cycle limitations for ground or flight start is 2 minutes on, 3 minutes off, followed by 2 minutes on and 23 minutes off. Low-energy continuous ignition must be used during takeoff, landing, turbulence, heavy rain, in conjunction with fuel heat, prior to activating or deactivating engine or wing anti-ice, and emergency descent. The continuous ignition switch controls the arming of the low-energy ignition circuit. With the start lever out of the cutoff position, moving the continuous ignition switch to on activates the low-energy ignition circuit. Continuous ignition does not have a time limit. Continuous ignition is overridden any time high-energy ignition is selected. Reverse thrust operation is restricted to ground use only. Prior to initiating reverse thrust, the throttles must be in the idle positions. Reverse thrust is most effective at high speeds. Below 70 knots, reverse thrust is less effective, and FOD danger increases on engines 1 and 3. engines should be in forward thrust by 60 knots. The reverse thrust levers control the mechanical operation of the thrust reverser directional valve. The reverser operating lights monitor the position of the clamshell doors. The lights are extinguished when the doors are locked in the forward thrust position. Raising the reverse thrust levers to the interlock positions locks the throttles in idle and mechanically opens the thrust reverser's directional valve, which allows 13th stage bleed air to release and extend the clamshell doors. The reverser operating lights illuminate when the clamshell doors unlock from the forward thrust position. When the clamshell doors reach the fully extended position, the interlock releases, and the reverse thrust levers can be raised to increase reverse thrust. Reverse thrust should be limited to the go-around EPR setting. After selection of reverse thrust, a go-around should not be attempted because forward throttle movement does not ensure forward thrust. To discontinue reverse thrust, lowering the levers through the interlock position repositions the directional valve and allows bleed air to retract the clamshell doors. As the clamshell doors begin to retract, the throttles release from their locked positions. When the clamshell doors lock in the forward thrust position, the reverser operating light extinguishes, and 13th stage bleed air is continuously applied to the retract mechanism. In flight, with the throttles at idle, reverse thrust selection is possible, but prohibited. The fuel heat system heats the fuel to prevent fuel icing. The fuel heat switches control the fuel heat valves. The fuel heat valve open lights monitor the position of the respective fuel heat valve. The lights are extinguished when the valves are closed. Prior to takeoff, fuel heat is used if fuel temperature is 0 degrees centigrade or less. All 3 fuel heat switches may be placed on simultaneously for 1 minute. When the fuel heat valve opens, the respective valve open light illuminates, and the oil temperature rises. This confirms that fuel heat is operating. In flight, prior to descent, fuel heat is used if fuel temperature is 0 degrees centigrade or less. With continuous ignition on, the fuel heat switches are selected on one at a time for 1 minute.